All right, thanks, Ian. Happy to be here. My name is Dan Gross. I am at Samsung, and I work at the Strategy and Innovation Center in San Jose, California. And right now I'm mostly focused on the ARTIK platform, which Samsung introduced a year ago. And I'll talk a little bit about that. But first, I wanted to show this slide. This is a site called Thingful. And what they're doing is tracking IoT devices around the world. And you can see I don't have any land imagery there. These are just all the things that are being tracked. And what's interesting is the different types of things that there are. There's everything from weather stations to power plants, to all kinds of things. And even in the oceans, you can see lots of dots in the oceans. Those are everything from buoys to barges, even whales and sea turtles and hammerhead sharks. So even, in IoT, animals can even be things. So that's quite interesting. So that's a pretty big picture of where all the things are. So what happens when we develop for things? You know, the IoT products that are out there. We have a lot of development challenges, and as you can see, just throwing up some buzzwords here, there's a lot of considerations when you develop for IoT. So you have to consider the OS, you have to consider the sensors that you're using, what SDKs are you going to use, what tools, and I'll talk a little bit more about what we're doing at Samsung with tooling. So this is the common architecture. I think everybody's slides so far have had some variation of this. With, at the bottom, we have edge nodes with sensors and actuators connected. We have gateways in our middle tier, and then we have one or more, clouds at the top end, and all connected usually via some kind of mobile device interface to interact with. So that's kind of the framework. That's the good news. So all of the considerations we had with what to choose, this seems to be overall the architecture that most folks are using. Now the bad news is that it takes a lot of effort to develop a product or an implementation for IoT. Typically, here's a Gantt chart showing everything from hardware design to software design, to implementing cloud services, from the kickoff to the various validation tests. We have several cycles of validation tests on to mass production. We're looking at typically 2 years for an IoT product. Now there's some that are faster, some that are slower, but in general this is kind of a good gauge. So at Samsung we looked at all of that and we thought, oh, okay, why don't we try to solve this problem? And one thing we introduced here is Samsung ARTIK, which is an end-to-end platform for IoT, which includes hardware and software and cloud and security and an ecosystem in order to address some of those problems. So the main goal of ARTIK is really, if you look at, typically we said, time to market is about 2 years. What we'd like to do is reduce that to 6 to 9 months, say, from a team size of 100 down to 30, say. So this isn't scientific by any means, but this is generally the goal of what we're trying to achieve. So why are we doing this? Why is Samsung, in IoT? Why are we looking at this problem in particular? Just a few data points about Samsung, if you didn't know. We're more than just a TV company. So we actually are the second largest semiconductor manufacturer in the world. We ship roughly 660 million products per year, which equates to about 2 million per day. And And actually, Samsung recently announced a commitment to $1.2 billion in R&D around IoT for the next 4 years. So Samsung's committed to IoT and trying to solve for that. So let's start with the hardware part of ARTIK, and I'll go through some of this stuff quickly so it's not too sales pitchy. So the modules that we announced last year and started shipping this year are, you know, the ARTIK 1, 5, and 10 we have in the family, and basically these are processor plus memory plus radios and storage. So you can see on our high end we have the ARTIK 10, which has 2 gig of RAM. It's an octa-core chip based on the Samsung phones, and it has 16 gig of storage. So if you look at the 5 and the 10, these are great modules for constructing, say, a gateway to run perhaps Kura. So one thing we realized is that we can make these modules, and the nice thing about the modules is that you can develop on them and also roll them out into your own product. And but on the software side, and especially on certain standards, Samsung is really not going to define everything for you. And so for ARTIK, we thought really we should embrace open standards. So as you can see here, going from bottom to top, we ship with Fedora. We also are working with Canonical on Ubuntu Core. Samsung also has Tizen Linux. Moving up, we support various common languages for IoT. And then connectivity, communication. We have MQTT with Mosquito, IoTivity, which is a project that Samsung supports through the OCF, WebSockets, HTTPS, all the open standards. You might have Kura on this slide as well. And then at the top we have the actual hardware connectivity, like Wi-Fi, Bluetooth, Zigbee, Thread. Okay, so that's the hardware and some of the open standards. But there's also this bit about data. There's lots of data out there, and I think this is from IBM. The source is IBM here, that there's 2.5 quintillion bytes of data generated per day. That's quite incredible. That actually equates to about 78 million Galaxy phones per day. We make a lot of phones, but we don't make that many. Another point is that a Boeing 787 Dreamliner airplane generates about 500 gigabytes of data per flight. So there's a lot of data being generated. So how do we harness all that? Well, one piece of the ARTIK platform is something we introduced this year, which is the ARTIK Cloud. So the idea here is that it provides a data exchange platform for you to develop against. And really the point of this cloud is that it can connect to any other cloud or any other device. And it has this concept of manifests, which allow you to define data types in a very rich set. There's also some fast onboarding features with the ARTIK. And the nice thing is you don't have to use the ARTIK hardware in order to use the ARTIK Cloud. So you could actually take a look at it today, if you like. And it has some really nice features, including a rules engine, which is configurable in the cloud and allows you to do quite a bit of interesting logic there. Okay, so we covered hardware, we covered the cloud, we covered our open standards. But what's missing? As we looked at our platform here, we thought the one thing that's a little bit still difficult for developers is the tools. How do you actually program applications on this platform? So we worked with our friends at CodeEnvy and with Eclipse, and we introduced the ARTIK IDE, which is basically Eclipse Che, which is a new Eclipse project that is basically a web-based IDE, and we've made a plugin essentially called the ARTIK IDE. So what does the ARTIK IDE allow? It has device discovery. It supports a variety of languages, as you would expect. There is an integrated real-time debugger that works on ARTIK devices. And there's, of course, version control. And, of course, we have integrated an SDK. So I'll go into some more of these examples here. So on the device discovery, I'm not sure if you can see here, but when an ARTIK device is on the network and you're running Eclipse Che, you'll see that the device is recognized, and you can connect to it over the device to deploy your code. So that's a nice feature. On the language support, you can see all of the syntax highlighting for C, C++, Java, JavaScript, and Python as well. So all of those languages will allow you you can edit your code in the IDE. And then there's actually a real-time debugger. So once you've developed your application and pushed it to the device, you can actually step through it in real time over the network, and that was done through a bridge that we developed that allows you to set breakpoints and all that sort of thing. It's really quite nice. And then finally, version control. This is expected. It's just integrated into Che. And then the other point is that with Che, it allows you to have consistent workspaces across different development machines. And right now we have a version that runs on your desktop, so you can fire up Eclipse Che and basically have a runtime there. But we're also exploring running the workspaces in the cloud, and so you wouldn't even need to download anything. You could just access the particular URL and be able to connect to your ARTIK device that way and deploy. Moving on. So the last part I wanted to talk a little bit more about is the SDK. So we recognize that there's a whole bunch of different libraries that IoT developers use, from sensors on up to middleware to cloud. And as we looked at those different libraries and APIs, we thought this is a real opportunity to consolidate some of these into one single package. So this is what we did with the ARTIK IDE. We actually integrated what we call the ARTIK SDK. And as you can see, it's a consolidated framework that brings together a lot of the low-level API calls that IoT developers are familiar with, things like GPIO, I2C, Serial, SPI, on up through the stack, including cloud APIs, as well as things like WebSockets and that sort of thing, and then on up to sensors and even media, so things like audio and video and those types of hooks, and then Bluetooth and Zigbee, of course, for communication. So I was going to step through a couple of examples here just to show you what that looks like. Here's an example of the API in an Eclipse Che window here, and this one basically just calls the media framework using C, and so you can see how easy it is actually just to play a simple sound file. You just define the sound file, and then you call the media module, and then play sound. And so that's quite easy, and that can be all part of the same application framework as any of those other APIs. So we also have hooks in JavaScript. So here's an example of using GPIO in JavaScript with the ARTIK SDK. So you can see here we're accessing the ARTIK 5 digital pin 0 and basically turning on an LED for 5 seconds and then turning it off. So that's what that code does there. Okay, so that's the ARTIK IDE. 1.1 is available today. I think that was released about a couple of weeks ago, and we're continuing to develop the IDE and the framework behind it. All right, so just kind of moving on with the rest of the ARTIK platform. Security is also a big component of IoT and something that we have as part of the ARTIK platform. So we actually have a secure element on the chip, which is a hardware security feature, and we also have various other security features, as you can see, like data encryption and privacy management in the cloud. And then finally, I wanted to mention that part of ARTIK is really our ecosystem. And we've been working with a number of different organizations to help grow the ARTIK ecosystem, and both open source as well as commercial organizations. And so, we're always very happy to work with everybody. Samsung is a big company, but we recognize we can't do it all, and so we really want to work with partners to grow the platform. So this is just the beginning. Samsung ARTIK is fairly new. It includes all of the various components for IoT, but there's still a lot more to do, and especially on the tooling side. But I think we're headed in the right direction. So hopefully that gives you a sense of what we're doing with ARTIK. Yeah, any questions? So the question was, can you use it with devices not on the internet? Yeah. So to take that. Take a scenario, say you could have, say a hybrid solution where an ARTIK device could potentially be disconnected and still have a lot of functionality locally because the processor is fairly capable. So there could be a lot of local intelligence built in. Yeah, Mark. So, yeah. So the question was, a lot of ARM vendors are carving out different niches, and where do we see ARTIK? Well, we see ARTIK really primarily targeted towards device manufacturers who want to build smart gateways, but Samsung itself isn't going to be the manufacturer of that smart gateway. What we would like to do is provide the tools and and the platform to be able to build those products. So it could be an end device, it could be a gateway. Really, we just I think don't envision becoming manufacturers of those, but want to provide the base hardware. Absolutely. So yeah, you can code it however you would like and connect to different cloud platforms. The ARTIK cloud has certain advantages, but it's not. It's certainly not the only cloud out there, and it doesn't have all the capabilities of all different clouds. So yeah. All of the software is open source. Yeah, I think that's the strategy that we're going to continue with. Is the cloud has a service fee, but the silicon you pay for. But beyond that, what you run on the hardware is up to you. And I think that open source now is much more leverageable than what we could produce to license. Yeah, that's a good question. So if we go back to my module slide here, we did announce the ARTIK 1, which is an edge node module. We have not shipped it, unfortunately, and but I think if you stay tuned, maybe in the fall you'll hear some announcements around edge nodes, perhaps. So stay tuned on that one. We don't have an edge node shipping, but we did announce it. It is GDB based. Yep. Yeah, we're trying our best there. It is a complex problem, and I think that's evolving, and we're gonna try to solve that as we go forward. Right now, I think you're identifying it is a little bit of a challenge to deal with the different tool chains, but we're getting there.
One last question. So I think you have some boards with you.
Oh, I do. Yeah, in my bag. Yeah. Yeah, and also I just wanted to point out too, so we have development kits available, but we also have a partner who developed a host board for one of the modules, which this is the whole board right here, which includes even a battery pack. And so so this is kind of a nifty little thing. If you want to see it, come find me. Oh, okay, yeah.
All right, thank you, Dan.
All right, thanks so much.